I'm Sarah Mei. I'm really happy to be here today. I just got in yesterday from London, so I'm pretty sure I'm here on the right day, but I'm not entirely sure. Hopefully, after a couple of nights of sleep, I'll be able to figure that out again. I am a Ruby and JavaScript developer here in San Francisco. This is me on Twitter and GitHub. This is my consulting company that I run. I do a lot of nonprofit work. I founded a nonprofit called RailsBridge that teaches women how to do Ruby on Rails and other underrepresented groups. I'm also a director of Ruby Central, which is a nonprofit that runs all the large Ruby conferences like RubyConf and RailsConf. And in addition to that, I also run our local Golden Gate Ruby conference, which is our regional one that we have here. And you may wonder, with all this Ruby stuff, why am I here? And that's a good question. The answer to that is that over the last few years, like a lot of people, I think, my work has undergone a pretty significant transition. Circa 2006, this is kind of what it looked like. I did a lot of Ruby. I did a little bit of JavaScript when I had to, but otherwise tried to avoid it as much as possible. I actually started doing JavaScript in the 90s, which was not a good time to start doing JavaScript. So it was pretty much always under duress. But like a lot of server-oriented engineers, I think, over the last 10 years, as full stack, quote unquote, has become kind of a thing, and as JavaScript has become more important, obviously, to a modern feeling application, the proportion of stuff that I do has shifted, and these days it's pretty much more like this. It's pretty much half and half, or more, sometimes JavaScript. And in the gap there, I've learned how to write it idiomatically instead of like a Ruby developer. I've gotten a little more involved in the JavaScript community. I enjoy it a lot more than I used to. But I am here as a bit of an outsider because I identify mostly within the Ruby community. And I feel like that actually happens a lot in the JavaScript community. People come in and they're PHP people or they're .NET people, and that's what they identify as. But it's shifting. It's shifting for me anyway. And I've been doing, for the last 5 years or so, I've been doing consulting through various companies. And it's not the traditional, like, take a project and do it off-site kind of consulting, but basically what I do is I go in and I embed myself into an engineering team. For a couple of months, I go to their office, I pair program with them, I work on stories, we level up. And these are teams that are working on fairly complex projects that typically have, as a minimum, these sort of major moving parts. They have a server, most often not JavaScript-based, because that's sort of where we are these days, at least at the moment. They've got a mobile app or a couple mobile apps, right? They interface with the server. And then they've got a browser experience that's a mix of client-side JavaScript and server-side rendering, typically. And I found this to be an incredibly common setup among small to mid-sized companies, at least in San Francisco. And so what I'm talking about today is mostly this stuff. Because I've seen lots and lots of different teams tackle this piece of an application using different client-side JavaScript frameworks. And mostly what I've seen is that people who don't do a lot of JavaScript, sort of going down the same road that I did, in which they start doing more of it. And I started noticing some patterns. I didn't think too much about it, though, until I went to the Fluent conference earlier this year. Anyone here go to Fluent? A few people. It's the O'Reilly Front-End Technology Conference. It's pretty big. I think it's 3,000 or 4,000 people, which feels really huge to me, given that I'm used to things more like this. O'Reilly is a fairly large, as you know, technology company. Here's one of their official pictures they released. Ticket prices for Fluent ranged from $1,500 to $3,500. Which I thought was kind of hilarious, and that's how you can tell it's a O'Reilly conference, right? Because they sprang for the super expensive, like they don't turn over name tags with 2 connectors, which is pretty cool. You know, the other option would be just to print it on both sides, like we did here. Seems like also an equally workable option. But you know, you pay $3,000, you expect fancy, right? That, and I think a keynote from Brandon Ike. So that's what your $3,000 gets you. But it's an interesting conference because as JavaScript conferences go, it's fairly conservative. it is one of those conferences that people whose companies will only send them to one conference a year go to a lot. And it felt like a more realistic cross-section of people who actually do JavaScript than something like one of these smaller community conferences. Because you do a conference like this, and you end up with sort of a small audience of really enthusiastic early adopters, which is great. And that's what I feel familiar with, that's what I feel comfortable in. But I don't think necessarily that we are a representative cross-section in many ways of the larger set of devs who do JavaScript. So Fluent was interesting for that. So while I was there, I actually spent a reasonable amount of time hanging out and just talking to people that I didn't know, which is hard for me as an introvert. Like I would go up and talk to people that I didn't recognize and be like, hi, tell me about yourself and why you're here. Because I was interested in finding out what they were there to learn. I met 3 types of people for the most part. I met backend developers, as you might expect, trying to become more full stack, whatever that means these days. And they came from a variety of backgrounds. There was some .NET folks, actually quite a few .NET folks, more than I expected, Java, PHP, Python, Ruby. Then there were the visual UX folks, and they were coming at it from the other direction, right? They're trying to learn more about front-end development from a, in many cases, non-developer background. And then, of course, there were a lot of front-end developers, already front-end developers, who were there to just learn about new technologies. So these are 3 groups of people with very different sets of past experiences, right? And what surprised me about it is when I talked to them about specifically why they were there, they all pretty much told me the same thing. Here's some quotes I wrote down. You can see if any of them feel familiar. My group has started an Ember project, so I'm going to every EmberJS talk on the schedule. Which Fluent has like 6 tracks, right? So there's pretty much always, any given time slot, it's pretty much, you could find one. My web app has an old jQuery code base, and I need to figure out what to do with it. A lot of that, surprisingly, I guess, but there's a lot of it. I want to learn about Angular. I think I can raise my rates. Almost certainly true. And finally, we have an ancient Backbone.js setup that desperately needs a rewrite, but I'm not sure in what. And I think by ancient, she meant about 6 months old at this point. But it was fascinating because no matter what direction these people were approaching front-end development from, they all kind of had the same question that they were knocking around, and that was, which front-end JavaScript framework should I be using? And that was the first time that I realized that some of the patterns I was noticing in my projects might be useful to surface in a more organized way. But I want to talk a little bit first about why we have this problem and why it seems so daunting, right? I mean, why we have this problem is at one level very straightforward, right? I mean, not Ember's fault, right? But this is the problem. There we go. In many ways, this is, of course, a really great problem to have. We have a lot of choices. There's a lot of projects addressing different facets of JavaScript organization in different places in our stack. It does seem like we have a few front runners, but it's still early, right? I mean, React has gotten a bunch of traction in the last, I would say, 6 weeks. It feels like a very short news cycle here, right? Ionic just got a bunch of funding a few months ago, so it's pretty early. It's pretty early. And you're looking all at this, and you're a developer. You have a specific project in mind, and it's really hard to tell what the right answer is. And that's where we come to blogs, right? That's where we turn. The internet has a ton of information about this stuff, and everyone wants to tell you about it. But it's really, really hard to sift through and find the little bits of actual useful information. In fact, I tried this last night. If you Google how to pick a JavaScript framework and you limit it to the past month, there's still more than 10 pages of results, which is crazy. That's crazy. And what all this adds up to is something kind of like this. So have a look at that and tell me whether you can park there at noon on a Tuesday. And you know, the different posts that you find when you go looking for other people's opinions about frameworks give you confusing and sometimes contradictory information. And this is also true at Fluent. One talk would be like, EmberJS is the best thing for data binding, and then in the same room in the next time slot was an Angular talk that was like, Angular is obviously the best for data binding. And your job, right, you've got a project, you've got a deadline, and your job is to synthesize all of this into some kind of decision. No pressure, right? But it's important. You know, really important, because the cost of being wrong can be very high. It's not just, are you parking illegally, might you get a $30 ticket? If you pick a JavaScript framework that isn't suited to your project or your team, it can be anything from sort of mildly inconvenient to disastrous, depending on when you figure it out. How far down the road do you go, right, before you find out that there isn't any more road to go down? So my goal for this talk is to help you pick frameworks with your eyes open. We're going to talk about a system for evaluation that I've synthesized from my experience and also from data that I've collected from other developers about their decision-making processes. Because ultimately, our goal is to get better at these large-scale decisions. But unfortunately, we don't make them very often. It'd be awesome if we did, right? Because one of the most effective ways for our human brains to learn something is repetition. And I'm sure you know that. I'm sure you've heard that before. We have a particular meme in our programming pop culture about that it takes 10,000 hours of practice to get great at something, right? Playing an instrument or programming, or whatever it is this person is doing. I don't want to do that for 10,000 hours, I'll tell you that right now. This is a huge oversimplification of how human beings learn. But the kernel of truth in it is that repetition actually is great for your brain. Your brain loves it. When we do things over and over, we get better at them. The key, though, which I think that this meme obscures for many people, is that it's not just the time spent, it's how you spend the time. You can spend 10,000 hours on something, but if you're not doing it right, those hours are wasted. So to really learn by repetition, what you have to do is do the action, analyze the outcome, repeat the action, changing it a little bit, that's the key part, changing it to see if that changes the outcome, and feeding that back into your loop. And even once you think you got it, even once you think you got that perfect cursive letter L, you need to keep experimenting, keep trying new things, and that's where learning actually happens. So the problem with this, though, is that if we're lucky, we might, over the course of our entire career, make large-scale technical decisions as many times as there are letter L's on that worksheet, maybe. So one way to get better at them is to wait 10 years, 15 years, to accumulate enough experience with this type of thing. Another thing we could do, though, is make an end run around this sort of time-based limitation by analyzing the decisions we do make all the time and then bringing that intelligence back to our framework choice. So that's what I did. I just did this talk in England, and I had to spend 5 minutes explaining what this slide was. I had totally forgotten about that. Anyway, so our technical decisions happen at very different frequencies and very different scales. So language and framework choices are the most infrequently made decisions that we have. However, there's a few more things that we do more frequently, such as decide whether to use some random code you found on GitHub or write your own. And even more frequently than that are all the technical decisions we make every day, which are things like, where does this code go? What should I call this variable? Is it time for me to write a test? Or should I go play ping pong? And what's interesting about these decisions at every scale is that even at the smallest, most frequent level, things we do every day, the process we use to make these decisions is pretty opaque. If you ask a programmer why they named a variable a certain thing, or why they put that function where they put it, often you get a somewhat unsatisfying answer like, well, it just seemed like the right place to put it. Or sometimes you get something like experience, intuition, gut feeling. When I ask programmers why they like Ember over Angular, or the other way around, I get very similar opaque responses. I get things like, it feels more natural. Hear that a lot. And I've heard that said about both Ember and Angular from different people. But as a scientist, I find that very unsatisfying. Obviously, we're collecting data. Obviously, we're doing something with it. So I wanted to investigate a little bit about what goes into that feeling. What goes into our gut feeling? What goes into our intuition? What data are we collecting? How do we organize it? What do we do with it? So ultimately, my goal was insights into these. So I took a look at those. Because as it turns out, I know a lot of people who evaluate libraries off GitHub all the time. And in fact, I'm sure you do too. So I asked a bunch of my colleagues to introspect for me and describe how they evaluate code they're considering using in their project. And the first time I did this, I started out by talking mostly to my Ruby friends. Then I expanded it. I asked some .NET folks I knew. I asked some Perl developers. I asked some JavaScript folks. And it was amazing that actually it doesn't vary a whole lot. It varies a little bit, but it varies fairly minimally. And so my list of things that they told me about, like, how do you evaluate a piece of code is huge. I would have to put it in very small font in order for you to see it all. So we're not going to look through it in detail. I'm going to put it up here just long enough for you to feel frustrated by not being able to read it. And then we'll go through it by category. We'll start categorizing stuff. So yeah, ridiculously small font. And that actually is about 2/3 of the stuff that I got. I sort of had to edit for length. But it turns out that all this stuff basically falls into 4 broad categories. So let's talk about those rather than going through the list one by one. These are the 4 categories. First one we're going to look at is interface. Interface is technical data about the library. This is things about its features, its functionality, its usage. What does it do, and how do you use it? This information is easy to find, usually on the README, if it's a GitHub project. These are the bits that are interface. This is basically what everyone starts with. Everyone starts with the README. README is a time-honored tradition. Here's one from 1936 about how to use the telephone. And it's pretty awesome because it's basically like every README on GitHub. Here's all the bullet points: how to operate, how to answer, how to clear, how to make calls. Great, right? All it's missing is installation instructions. I guess that comes in the 5-book supplement later. So here's a more modern version, slightly more modern version. README tells you what it is and how you do it. And so when you're considering interface, you're basically trying to figure out, the question you're trying to answer is, will this code be sufficient for what I need it to do? And most often in most projects comes to the README. In some cases, you may need to drop it in and mess around for a while if the documentation is particularly poor. But that's one category of evaluation. The second is activity. This is things like looking at the number and recency of commits on GitHub. You don't want something that's abandoned, right? Looking at the GitHub issues and pull requests, how long have they lain dormant? It also includes things like when was the last release? How up-to-date are the official docs? In general, with this category of evaluation, we're trying to figure out how often is it updated? How likely am I to get help from the maintainer, get a pull request merge, things like that. It's this stuff. Activity. Is this project sufficiently active that I can depend on it? Next category is popularity, meaning amongst other developers. How easy will it be to find help when I run into a problem? Can I hire somebody who's used it already? How likely is it someone else has already fixed a bug by the time I get there? To figure this out, we look at things like how many tutorials and blog posts are there when I Google it? Right? How many Stack Overflow questions are there, and have any of them been answered? We also ask other developers we know, either directly or in kind of a meta way through Hacker News or Reddit or Twitter or something like that. We look to see whether it's been mentioned on news sites, podcasts, things like that. And these things are basically popularity of a project. And we're left with a couple outliers, evaluating the code directly and evaluating the tests. These are things that I call accessibility, and this one's a little weird. The other 3 categories are pretty straightforward, and they have pretty well-known sources of data. You could probably write a script that would give you some kind of relative score for those other 3 things, right? Interface, activity, popularity, relative to other libraries. But what we have left is a little fuzzier. It's really about how familiar things feel to you. Is this code idiomatic? Does the maintainer share my test strategy? How much does the code match up with what I would write if I were going to roll my own? How much does this code feel like other code I've seen? How does it feel to use it? Are the author's ideas about programming the same as mine, essentially? So there you go. Those are our 4 categories. And these are the types of things we consider, usually unconsciously, when we're making a smaller scale decision. Now, at the level of, like, should I use jQuery cookie? It's probably not worth explicitly going through and thinking about all of these things. Instead, what happens, right, is you poke around on GitHub, and then you kind of make an intuitive, quote-unquote, intuitive judgment one way or the other and move on with your life. It gets interesting, though, when we start applying these categories to the larger scale decisions, like frameworks. First, let's do a little bit of meta categorizing, because we can actually start drawing some lines here. You ready? We're going to make quadrants. Quadrants are very exciting. Apparently, this is a thing. So first of all, you can draw one line here. The 2 categories on the top, the accessibility and interface, are both about you. Interface is about whether the code can actually do what you need it to do for your project. And accessibility is about whether your team feels comfortable with the metaphors the project uses in its code. It's called internal stuff. On the bottom, These two categories are about the people and project outside of your team. And so popularity and activity measure external factors. So we have that divide, and then of course we have another one. On the left side, accessibility and popularity both have to do with the people around a project. Accessibility is whether or not your people can use it. Popularity is whether or not other people are using it. And on the right side, interface and activity are both information about the project itself. The interface is whether the framework does everything you need, and the activity, while it's of course generated by people, is ultimately about the project. It's about whether or not you can count on bug fixes and improvements down the line. So there you go, there's my 4-quadrant system for making technical decisions. I was showing this talk to a friend and we got to this part and he was like, this is awesome. Because you know, consultants are supposed to have a system they're selling, and you're a consultant now. So you've got to have one. You should definitely use this one. It's got the right number of quadrants. Everything's going to be awesome. And I thought, if I'm going to own this, I got to own it, right? I got to give it the super narcissistic title. Here we go. Oops, there we go. People, project. The Mei system. Thank you very much, ladies and gentlemen. This really makes you want to throw like $500 an hour at me, then let me know. Otherwise, I think I'm going to stick to my pair programming approach, if that's okay with you. So far what we have is interesting, but maybe it's not yet useful. We've captured the practices people actually do into categories. Categories are pretty awesome. I like these categories. But the categories really only become powerful when we apply them to the higher risk problem. So let's look at how you would apply these to a higher risk problem like picking a framework. I mean, I guess we could try applying these, but let's apply the other ones. These would be an interesting separate talk. So let's start with interface. Interface is pretty straightforward, right? The interface of a framework is what's in the Angular README, it's what's in the Ember README. It's what's in the intro tutorials. These are the bullet lists of features that make up most of the blog posts that talk about picking a framework. Next, we have activity. Largely the same also as at the smaller scale. You can get this by looking at the GitHub project. You look at the release schedule, look at the docs. Popularity also largely the same. Stack Overflow content, percentage of hacker news arguments, number of recent blog posts. So these three, again, pretty straightforward. Once again, the interesting one is accessibility. Because in client-side JavaScript land, where we are today anyway, there are quite a few frameworks with a sufficient interface, sufficiently popular, and sufficient activity. Because we've got this huge crowded field, but it feels like in the mainstream today, we're kind of looking at that. We've got Backbone, we've got Angular, and we've got Ember, and all three of these can do what your application needs it to do. They're all reasonably popular. They're all reasonably active. The only way that we as developers can really distinguish them from each other is accessibility. But it's pretty hard to untangle what accessibility means with a framework. And this is why we fall back on things like it feels more natural when people ask us why we like one or the other. But over time, with the projects I've done, I've seen lots of developers try, and in some cases struggle, with different client-side JavaScript frameworks. So to explain how accessibility plays out here, I want to start with a little bit of history about how the Java programming language and JavaScript have historically gotten along. I took it off my resume, but I actually used to do Java back in the day, in the late 90s and early 2000s, which was really, really not a good place to be if you were a JavaScript developer at a time. For a long time, the Java relationship with JavaScript was very sad, despite the name confusion. The state of the art for a while was something called Java Server Faces. I don't know if anyone remembers those. I've tried to push them out of my mind as much as possible. They are packaged front-end widgets, usually with a really old version of jQuery. And to put one on your page, you just put a little directive in your markup, and it spews a bunch of JavaScript into the page. And it hooks up automatically to your backend, and you never have to write any JavaScript. And that is considered a feature. And in that way, and in many other ways, the Java community has, over the years, put a pretty intense amount of effort into avoiding JavaScript entirely, as much as possible. There were other efforts in this direction. I don't know if anyone remembers Google Web Toolkit, right, which was like, write Java, compile down to JavaScript, never have to write any JavaScript that way. There are more modern approaches, things like Dart, They're basically all efforts to allow Java developers, of which there are hundreds of thousands, to write JavaScript without actually having to learn it. However, in the Java world these days, there's a new contender. That, of course, is Angularjs, written by Java developers, and featuring a dependency injection structure eerily similar to those found in modern Java backend web frameworks. So, if you come from the Java backend world or the .NET backend world where dependency injection frameworks are standard practice, Angular is going to feel pretty familiar. It'll feel accessible, right? And this is a huge step forward for the Java world because it's real JavaScript this time, which is great. Super excited about that. However, it has a structure layer on top of it that makes it less risky for them to adopt, because they can do JavaScript without having to learn an entirely new development paradigm. And conversely, for those of us who don't come from Java or .NET, the dependency injection in Angular feels pretty disorienting at first. It's fun. It's neat to get your head around, but it's disorienting a little bit. And that makes adoption riskier because we have to take on the cognitive load of understanding the framework and understanding the concepts that it presents, in addition to trying to actually get shit done. And of course, there's a learning curve on any JavaScript framework for any team. But finding a framework that fits the way you already think makes the adoption less risky in some ways. And so that's what accessibility measures at its core. It measures how steep the learning curve is likely to be for your team. To give you another example, we have EmberJS with a mascot that is a hamster, apparently. Someone told me the other day it's called a Tomster because Tom Dale has glasses that look like that or something. I don't know. Anyway, I don't find the hamster quite as creepy as the gopher. I don't know if any of you have seen the gopher. This is the most freaky conference logo I've ever seen in my life. I think Go as a language is fascinating, but they really got to do something about that because that is super creepy. Anyway, hamsters. Back to hamsters. Tomsters, whatever. So EmberJS was built by Rails developers, and it features at the center of all Ember applications a router, which is a piece of code that takes in a request URL and decides what code to run as a result of that URL. Now, this is eerily similar to what you find at the center of all Rails applications. And this concept that the routes coming in determine what code gets called flows from REST, which is a relatively new idea, or rather relatively new to be popular, let's put it that way. So if you come from a web framework that matured in the RESTful era, something like Rails or Django, EmberJS will feel very accessible. It'll feel easy, it'll feel natural. On the other hand, if you come from Java or .NET or another web framework that matured before REST was a popular thing, then you are used to having much more control over what happens exactly to a request. And because of that, Ember may end up feeling a little bit overly constraining. And finally, a last example, Backbone, which is the oldest of this set, was graduated out of a server-side app in the 2008-2009 timeframe. I know it's hard to think back that far, at least it is for me, but that was before the idea of single-page apps was really a thing. I think there were a couple people over in a corner doing like cappuccino somewhere, but pretty much most people thought about JavaScript as something that decorated a server-rendered page. So you'd render a view, you'd assemble some JavaScript, you'd shove them down the pipe together to the client, and once they got there, the JavaScript would add a veneer of interactivity over the markup. And so if that's the kind of web application that you're still building, yeah. Is it 420 yet? That's what that usually means. So if you still think about web applications as some markup and a veneer of interactivity on top, and if your web application is still thinking about pages in that way, then maybe Backbone will feel natural. It'll fit the way that you already think about things. And it may not be convenient sometimes, but it does have a bunch of descendants that might be more convenient. But if you're one of these kids today that thinks about a web application as a bunch of JavaScript that runs in a browser and like creates some markup and then goes out to the internet to get data once in a while, then Backbone is going to feel completely wrong. It doesn't fit that type of project. So for this framework, the accessibility judgment flows from the types of projects you've done, rather than necessarily the technologies you've done them in, as with Angular and Ember. And accessibility is a judgment that comes from a lot of different sources when we're talking about frameworks, just because they are more complex than something like jQuery cookie. So one source is the set of technology stacks you've worked with over the years. Another source is the type of projects that you've done, what industries you've been in, and so on. And oftentimes, in a single project, you may have more than one thing that's contributing to this judgment. So for any given decision, accessibility is kind of the most difficult of these to figure out because it's not like the Angular guys have a bullet point in their README that's like, by Java developers for Java developers, right? Because everyone who's building a framework thinks they're building it for everyone. But they're all wrong. What they're actually doing is turning the way that they think into code. They are codifying their assumptions into code. And so I guess the question is, how do you see that? Besides coming here and listening to me make quadrants for half an hour. And the answer to that really is, as fun as it is to talk about it, you probably don't actually need to know what their biases are when you're making a decision because you'll be able to feel how well they line up with yours. You'll be able to notice the amount of ease or the amount of unease that you feel when you're working with a framework. And the last thing to consider is that even once you're explicitly thinking about accessibility, it may not always be the most important factor in your decision. Sometimes you have a team that's overtaxed, and you need a way to adopt a new technology that's as close as possible to what they already do. But other times, you and your team are ready to do something challenging and new and different. Sometimes you want popularity because you know you're going to need to hire 5 people in a tight time frame. Sometimes you pick something totally unpopular because it has that one feature you need, right? But the key here is to remember that when you're making a decision, make sure that you're explicitly thinking about each of these 4 quadrants of things. Because when you're doing a large-scale technical decision, it's more important to make these things explicit than it is when you're talking about jQuery cookie. So finally, I want to close with something I saw in Hacker News a couple of months ago. Or actually, I didn't see it. Steve Klabnik saw it, and he reads Hacker News, so I don't have to. And the context here is a blog post about Nimrod, which is an obscure programming language. And one of the commenters talks about all the great features it has, how great the interface is, and he says, the only reason Nimrod isn't popular is because people don't evaluate things logically. And he was clearly very frustrated. And I actually sympathize with that point of view because the decisions that other people make really do look mysterious if you think that like this is all there is to think about when you're evaluating a technology. And you see this a lot, especially online, maybe perhaps especially on Hacker News. You see things where people think that considering the other 3 quadrants rather, is just illogical, that really all you should care about is interface. Which is an interesting point of view. I mean, Nimrod is failing to catch on. He's quite right about that part. But it's not because people are illogical. It's failing to catch on because, he's here, but we're at the top right there, and we can see a little bit more expansive view than you can from down in the valley. So even though we can't repeat the language or the framework decision more often enough to learn from the repetition, you can take these categories and at least let them expand your vista a little bit when you're thinking about large-scale technical decisions. And a very wise man once said, change of perspective is worth 80 IQ points. And I would say with this stuff, a change in perspective is worth 80 IQ points and possibly about maybe 5 years of experience or so. That's all I got. Thank you very much.